Okay, here we're going to be practicing writing out hypotheses for our hypothesis tests. So we're not going to be doing a complete hypothesis test in any of these examples. We're just practicing writing down the hypotheses. So here's our setup. Politician's concerned about his approval rating. His advisors hope that more than 40% approve of him. So the first thing we got to decide our population and what we're calling success. Remember, these are groups, not numbers. So here population would be voters, and the successful ones approve of him. So this is the important step. We have to write this on every problem. Let P be the proportion of the population that is successful. Then our hypotheses, the number we're concerned with is it 40% or is it above 40? So the null hypothesis is P equals 0.40, meaning 40% of voters approve of him, versus the alternative, P is greater than 40. Why do we use greater than? It says above right there. When we actually do a problem with this, we'll have a sample that also suggests that more than 40 approve of him. Okay, another example. Only 20% of people who try to quit smoking are able to do so. These guys are selling this motivational tape and they think they can get that number up. They think they can get above 20% to quit smoking. So here, P then will be the proportion of smokers who quit. Success is they quit smoking. Population is smokers. Our hypotheses then will be the null is P equals 20%, because that's the general population. We believe 20% quit smoking. These guys think they can do better than that, so the alternative will be P is greater than 20%. Notice we're always using the same number here and here. The only thing we got to figure out is whether we're writing greater than, less than, or not equal to. And the words in the problem and the sample will tell us what to write here. Okay, here, another example. Back in the 50s, 42% of people that went to high school, or of high schoolers went to college. We want to know if there's been a change. Oh, went the wrong way. So P here will be the proportion of high schoolers that go to college. Our null hypothesis is that nothing has changed. It's still 42%. P equals 42%. Our alternative here, this is a two-sided hypothesis test, is that the number is no longer 42%. And we know that because the question says, has that percent changed? If it said increased, we would have written greater than. If it said decreased right here, we would have written less than. We don't care in this case whether it went up or down. We just want to know, did it change? So we'll do not equal to as the alternative. One more example. Is a coin fair? We're flipping a coin over and over again. We want to know, do we get 50% heads, 50% tails? So our population will be coin flips, and then for success, we'll just randomly, we'll say heads is success. We could have easily chosen tails, but I chose heads. So P then will be the proportion of heads. We would expect, if the coin were fair, that we would get 50% heads. So our null hypothesis is the coin's fair, 50% heads. Now, if you're flipping a quarter and you get 75% heads or 75% tails, either one of those is a bad coin. And we don't really care which way it's bad. If it's bad, it's bad. So if we don't get 50% heads, it's a bad coin. So this is the null hypothesis is the coin's fair, and the alternative is the coin is not fair. It's not 50%. This would be a two-sided hypothesis test.